Logarithmic functions are the inverses of exponential functions, similar to the way that square roots are the inverses of square functions. So supposing I put 2 into this original function, I get y is equal to 2 squared, this is equal to 4, and now I want to know the inverse of it. I want to know what number squared gives 4. I have to put this in the inverse function. So I put in 4 for the inverse function, and I get 2. I get back what I started. Similarly, for exponential functions, I have y is equal to a to the x. And supposing I take the example y is equal to, let's say I have a base of 2 to the x, and then I put in x is equal to 3. So I have y is equal to 2 to the third, which is equal to 8. And now, suppose I want to undo this. I want to know two raised to what power is equal to 8. We use a similar method. So I start out with the original function, and in order to find out the inverse, I must switch the y's and the x's. Similar to the way that we did for finding the inverse of a square root. So I'll start with the square root. Y is equal to x squared. To find the inverse function, I switch the y and the x. X is equal to y squared. Take the square root of both sides. The square root of x is equal to y. So that's the inverse function. So to find the inverse function of this, I switch the x and the y. And now this becomes a notation issue, because I'm looking for a to what power, a to what y gives x. And that's what this written up here is. Now this is where the logarithm notation comes in. Log of ax is equal to y. And what this reads as is a to what power gives x. So if I have my result, actually let's use this original equation. So I have 8 to 2 to the x. So I want to know what power of 2. What power of 2 gives 8? So to write this in the logarithmic form, I write log of 2. So 2 to what power gives 8? And that's what the y is. The y is the exponent. So the solution of a logarithmic equation is an exponent. That is this. So what it's doing is that it's undoing an exponential function. So let's do a few examples. The key to understanding logarithmic functions is just to understand the notation, because it's really not any different than doing a square root or something like that, something that people in general are more comfortable doing. People aren't uncomfortable necessarily doing square roots usually, but they are uncomfortable doing a logarithm, and it's mainly because of the way it's written. So the key to mastering logarithms right now is just to understand the notation. So let me practice the notation a little bit. Let's begin with some very easy ones. Supposing I want to write this in logarithmic form. So this is in the form of an exponential function. Y is equal to a to the x. And to write it in logarithmic form, it has to be written as log base a x is equal to y, where y is the exponent. See, exponent, and this is the base. And this is what it's equal to. I don't really know what to write that as, but whatever it's equal to. So what I like to do is to say what I'm doing every time I write out a logarithm. I start with the base, so log of base 4. So what I'm looking for is 4 to what power gives 64. 4 to what power gives 64? And the answer is the exponent, 3. 4 to the third is 64. What exponent of 4 gives 64? And then we're looking for the answer. Let me do one more. That'll be a little bit trickier. Not really trickier, it's just different. So suppose I have a to the minus 2 is equal to 7. Here it's the base that's unknown, but it's still written like any other logarithm. So logarithm of base a. So a to what power gives 7? And that power is 2. That's how we write that one out. I might as well circle this one too. And for now, this is all I'm really going to spend time discussing. For right now, it's just a notation, because the notation is very important. If someone does not understand the notation, they're never going to understand logarithms. But we only not have the capability, well, we have the capability also of going from logarithms, so from this logarithm form to exponential form. So not only can we convert this to this, but we could also convert it right back. So let's do a few of those. Suppose I have log base 3 of 243 is equal to 5. And I want to convert this to exponential form. So I have logarithmic form and I want to convert it to exponential form. The best thing usually to start is with the base. So here I can see it's a base 3. So 3 to what power is equal to 243? That's what this logarithm is saying. 3 to what power is equal to 243? 3 to the power of 5 is equal to 243. That's all there is for that. This is a relatively simple process. It's just getting used to it is all. Well, let me do one more. Say I have log a to the n is equal to whatever, 5. And I want to convert this back into exponential form. So what I'm going to do is I'm going to start out with the base. The base here is a. A to what power gives n? So a to the 5th gives n. A to the 5th is equal to n. That's all there is to it. It's not any more complicated than that. It's just all that really people need to do is to get accustomed to the notation, because it's exactly the same thing as a square root or any other inverse function, but it just looks a little bit different. And sometimes people will be thrown off by the fact that there's log and there's three numbers, and it's not really any different than anything else that we've been doing. So practice notation and tell yourself what you're doing every time, because then it's very easy to remember what you're doing. Sometimes people do understand how to use logs, but they don't understand what it is they're actually doing. So when it comes time to actually apply logs to a problem, they're not really sure what a log is. And really what a log is asking is, what power of some base gives this number next to it? So what power of 3 gives 243, and that's 5. So tell that to yourself every time if you're having trouble understanding what a log is. So what power, or what exponent, let me write that, of A gives X. That's the easiest way to think of it.